When people talk about Linux today, the conversation is very different from what it was 10 or 15 years ago. Back then, Linux was framed almost entirely as an alternative. Something you used because you rejected Windows or Mac OS, because you cared about freedom, or because you wanted control at the cost of convenience. Today, Linux is everywhere. It runs most of the internet, dominates cloud infrastructure, powers Android phones, smart TVs, cars, routers, and even gaming handhelds. On the desktop, it has never been more capable, more polished, or more accessible. And yet, despite all of this success, modern Linux has a problem. In fact, it has several problems, and they're not the same ones we used to complain about. These aren't just issues of missing drivers or ugly interfaces anymore. The problem with modern Linux is complexity, fragmentation, inconsistency, and the growing gap between what Linux can do and how hard it is for regular users to understand what's actually going on. What makes this story interesting, though, is that Linux distros themselves are increasingly aware of these problems, and many of them are actively trying to fix them in radically different ways. One of the biggest problems with modern Linux is that it has become incredibly powerful, but also incredibly complicated under the hood. For developers and experienced users, this power is a strength. You can customize almost everything, swap components, rebuild your system from scratch, and tune it exactly to your needs. But for newcomers and even intermediate users, this flexibility often turns into confusion. There are multiple init systems, multiple audio stacks, multiple display servers, multiple package formats, and multiple ways to configure nearly every subsystem. When something breaks, the fix might depend not only on what distro you're using, but also on which desktop environment, which session type, which driver version, and which packaging system you've chosen. This means that advice found online is often outdated, incomplete, or only valid for a narrow set of systems. A command that works perfectly on one distro might fail entirely on another. A configuration file that exists on one system might not exist at all on another. This fragmentation makes Linux feel unpredictable, even when the underlying issue is something small. Another major problem is software distribution. Traditionally, Linux relied on distro-specific package managers and repositories. This was one of Linux's biggest advantages over other operating systems. You could install almost everything from a central, trusted source, update your entire system with a single command, and avoid the chaos of downloading random installers from the internet. Over time, though, this system began to crack. Different distros shipped different versions of libraries, different toolchains, and different policies about stability versus freshness. Developers who wanted to distribute software to Linux users had to choose between targeting a specific distro, maintaining dozens of builds, or asking users to compile from source. This led to outdated software in stable distros and unstable systems in rolling release ones. For users, this meant choosing between reliability and access to modern apps, often without fully understanding the trade-offs. Then there's the desktop experience itself. Modern Linux desktops look better than ever. Animations are smooth. Scaling is mostly fixed. Wayland is becoming the default, and hardware support has improved dramatically. But under the surface, there is still a lack of coherence. Different desktop environments have different design philosophies, different settings layouts, and different expectations about how users should interact with the system. This is not inherently bad, but it becomes a problem when core behaviors change depending on what environment you're using. Keyboard shortcuts, system tray behavior, notification handling, and even basic features like screen sharing can behave differently across desktops. For users coming from Windows or Mac OS, this can feel like constantly moving the furniture around in a familiar house. You know where things should be, but they're never quite where you expect them to be. Another issue that has grown over time is the tension between stability and innovation. Linux moves fast. New kernels, new drivers, new file systems, and new frameworks are constantly being developed. This rapid pace is one of Linux's strengths, but it also creates friction. Some users want a system that never changes, where updates are rare and predictable. Others want the latest features as soon as possible. Traditionally, distros solve this by positioning themselves along a spectrum, from ultra-stable enterprise systems to bleeding-edge rolling releases. The problem is that modern users often want both. They want stability for their work, but they also want modern hardware support, new desktop features, and up-to-date applications. Balancing these competing demands is one of the hardest challenges for distro maintainers. Security is another area where modern Linux faces a paradox. Linux is widely considered secure, and for good reason. Its permission model, open development process, and rapid patching culture make it resilient against many types of attacks. At the same time, the security landscape has changed. Desktop Linux users are now more likely to install third-party software, use proprietary drivers, and integrate with online services. This increases the attack surface. Traditional Linux security tools like SE Linux and AppArmor are powerful but notoriously difficult to configure and understand. For many desktop users, these systems are either disabled, misconfigured, or invisible until something breaks. This creates a situation where Linux is secure in theory, but often confusing in practice. So how are distros responding to these problems? One of the most significant trends in recent years is the rise of universal packaging formats. Technologies like Flatpak, Snap, and AppImage aim to solve the software distribution problem by bundling applications with their dependencies and running them in isolated environments. This makes it easier for developers to ship one build that works across many distros, and easier for users to install modern applications without worrying about breaking their system. Flatpak, in particular, has gained widespread adoption on the desktop. It integrates well with graphical app stores, supports sandboxing, and allows users to choose between stable system libraries and newer app runtimes. While these formats are not without criticism, they represent a clear attempt to reduce fragmentation and make Linux more approachable. Another major response is the move toward immutable or semi-immutable systems. Distros like Fedora Silverblue, openSUSE MicroOS, and SteamOS take a radically different approach to system design. Instead of treating the operating system as something you constantly modify, these systems treat it as a fixed image that is updated atomically. Applications and user data are separated from the base system, often using containers or sandbox packages. This approach dramatically reduces the risk of system breakage, makes rollbacks easy, and simplifies updates. For users, it means fewer mysterious failures after updates and a clearer mental model of how the system works. For developers and maintainers, it means more predictable environments and easier testing. Some distros are tackling complexity by embracing opinionated design. Instead of offering endless choices during installation, they make decisions for the user. They choose a specific desktop environment, a specific set of tools, and a specific workflow, and then focus on polishing that experience. Pop_OS is a good example of this approach. It doesn't try to be everything to everyone. Instead, it focuses on productivity, tiling workflows, and seamless hardware support, especially for laptops and workstations. By narrowing its scope, it reduces confusion and provides a more cohesive experience. Other distros address the problem by rethinking configuration itself. NixOS, for example, treats the entire system configuration as code. Instead of manually editing files scattered across the file system, users define their system declaratively in a single configuration file. This makes systems reproducible, easier to version control, and easier to roll back. While this approach has a steep learning curve, it directly addresses the problem of unpredictability and inconsistency. Once you understand the model, you always know exactly how your system is defined and why it behaves the way it does. Hardware support is another area where distros are actively improving. Modern Linux has excellent support for a wide range of hardware, but the experience can still vary depending on drivers, firmware, and kernel versions. Some distros are focusing on tighter integration with hardware vendors. Ubuntu works closely with OEMs to certify laptops and desktops. Fedora often ships newer kernels to support the latest hardware quickly. Specialized distros like Cashos or Garuda Linux focus on performance tuning and gaming optimizations out of the box. These efforts reduce the gap between Linux and other operating systems when it comes to plug-and-play usability. Desktop environments themselves are also evolving to address long-standing issues. The transition from X11 to Wayland is a major example. Wayland improves security, performance, and consistency in many areas, but the transition has been slow and sometimes painful. Modern distros are increasingly making Wayland the default while smoothing over rough edges, improving compatibility and fixing long-standing bugs. At the same time, desktop environments like GNOME and KDE Plasma are refining their interfaces, reducing visual clutter, and focusing on clearer workflows. This doesn't eliminate choice, but it makes each option more internally consistent. Another important change is the growing focus on onboarding and documentation. Many modern distros invest heavily in welcome screens, guided setup tools, and graphical system settings. These tools help users understand what makes a distro unique and how to perform common tasks without diving into the terminal. This is a subtle but crucial shift. Instead of assuming that users will eventually learn everything through trial and error, distros are acknowledging that good guidance is part of a good user experience. Community culture is also changing. In the past, Linux communities sometimes had a reputation for being unwelcoming to newcomers, dismissing basic questions or responding with overly technical answers. While this still exists in some corners, many distro communities are actively trying to be more inclusive. Clear documentation, friendly forums, and active moderation help lower the barrier to entry. This cultural shift is just as important as technical improvements, because the perception of Linux is shaped as much by its community as by its code. Of course, not all problems are fully solved, and some never will be. Fragmentation, for example, is both a weakness and a strength. The same diversity that causes confusion also drives innovation. Different distros can experiment with new ideas without forcing everyone else to follow along. When something works, it spreads. When it doesn't, it fades away. This evolutionary process is messy, but it's also why Linux continues to adapt. The real problem with modern Linux, then, is not that it's broken or outdated. It's that it has outgrown its original assumptions. It's no longer just a hobbyist's operating system or a server platform hidden away in data centers. It's a general-purpose platform used by people with wildly different needs and expectations. The tools and workflows that made sense when Linux users were mostly technical experts don't always scale to a broader audience. Recognizing this is the first step toward fixing it. What makes the current moment exciting is that distros are not ignoring these issues. They are experimenting boldly, sometimes controversially, to find better models. Universal packages, immutable systems, declarative configurations, opinionated designs, and improved onboarding are all attempts to answer the same fundamental question. How do you keep Linux powerful without making it overwhelming? There is no single correct answer, and different distros are exploring different paths. In the end, the story of modern Linux is a story of growing pains. The platform has succeeded beyond what its creators could have imagined, and now it has to adapt to that success. The problems are real and sometimes frustrating, but they are also a sign of progress. Linux is no longer struggling to survive. It is struggling to mature. And if the current wave of distro innovation is any indication, the future of Linux may be less about fixing what's broken and more about refining what already works, making it accessible, understandable, and reliable for everyone who wants to use it.